In example 3, we need to solve the triangle, and we're given that the measure of angle B is 35 degrees, A is equal to 20, and B is equal to 16. We don't know that this is a right angle, so kind of right now automatically I'm thinking that we're going to need to use either the law of sines or the law of cosines. Love drawing a picture for these, or the triangle itself. So let's see here if we can draw maybe B here. That's about 35 degrees, or exactly 35 degrees here. The picture is approximate, of course. We'll make A over here. We'll go A, B, C. And A was 20, so that's this side over here. And B is 16. We need to be very careful with this situation because we have an angle side-side or a side-side angle. So we're going to need to investigate case 1 and also case 2. Your givens won't change. So the measure of angle B is 35 degrees. We will try to find the measure of angle A and the measure of angle C. And then we're given A is 20, B is 16, so we need to find C. And the same thing would apply here. The measure of angle B is 35 degrees. We're trying to find also the measure of angle A in this case. Measure of angle C here. A has to be 20 and B has to be 16. So there are 0, 1, or 2 possible solutions. We're going to investigate that here. Just know that the given information needs to be the same for each case. When I look at this, I'm thinking law of sines right away. I think that's going to be the easiest. If we can find this angle A, then we could find angle C, and then use the law of sines again if we need to find this side length over here. So let's see if we can set this up for angle A. We'll do the sine of angle A over its opposite side, which is 20. And then we're going to have the sine of 35 degrees over its opposite side, which is 16. To solve for this angle, what we need to do is multiply by 20 on each side. So we'll have sine A is equal to 20 sine of 35 degrees over 16. Remember, when we're solving for an angle, we need to use the inverse. So angle A will be the inverse sine of this whole expression on the right-hand side there. So let's see how we type this in. We'll have the inverse sine, which is second sine, 20 sine of 35, close parenthesis. We'll divide that by 16. Also make sure that you're in degree mode. We're using degrees here, and you can hit that at any time. You can just go to mode and verify you're in degree mode, and it'll bring you right back to this one. So it's 45.8 degrees, or about 45.8. We're not told to round here on this one, kind of left that off of the example, so let's just round to the nearest tenth. I think that'll be nice. Remember that if the measure of angle A here is 45.8, this guy could swing over and could contact this side right here, so that's our other possible. And this angle A, which is 45.8, and this angle A, there could be 2 points there. Well, it just depends which triangle you have. It's still point A. This angle is supplementary to this one. So all we need to do to find the measure of angle A for the second case is take 180 and subtract what we got before. And I like to use the answer function here, but it's not necessary that you do that. You can just do 45.8 if you want. So that's 134.2 if we keep with our rounding. And that's in degrees. One thing we can look at here is the angle measures, and we can add them up. And the other one should need to add up to 180 degrees. So we could take 35 plus 45.8. We'll take 180 and subtract that amount. That'll get us the third angle of that triangle. So that's 99.2. This is a possibility, so we're good with that. This other one over here, sometimes you can get angles that don't make sense for a triangle. So if this was like 150, that'd be 185, and this wouldn't make sense. Then you could cross this off. That wouldn't be a possible triangle. But if we add 35 and 134.2, whoops, hopefully you can see that here, we get 169.2, so we'll take 180, subtract that amount, and that'll give us our third angle of 10.8 degrees, or about 10.8 degrees. When we find side C here for each one of these, we're going to need to use the values in this case separately, and then we'll find C for this case. So to find C, we're going to set this up with the law of sines. Measure of angle C is 99.2. We're about 99.2. And then we can pick any of the other ones. I like to choose 16 and 35 degrees. It's what we're given, and it's the most precise. So we'll do 16 over the sine of 35 degrees. Notice in this second case, it's going to be C over, except the measure of angle C is only 10.8 for this one. However, we were given 16 and 35 degrees, so that will stay the same. We really only need to change one thing, and that's at angle C. Solving for C here, we would multiply each side by sine of 99.2. So C is equal to 16 sine of 99.2 over sine of 35. We've been using degrees all along, so we should be okay with our degree mode. So we can go sine of 99.2, close your parenthesis, divided by sine of 35. And that's 27, or about 27.5. So the C in this one is about 27.5. Remember, this first case was this triangle right here, so we can tell that this one is going to be fairly long. And you can double check your work. The measure of angle C is the largest one out of these three, and so 27.5 does make sense. It's the largest out of these three. If you get a little bit crafty with this, you can just hit second entry, and remember the only thing that was different was the 10.8 where the 99.2 was. So you could just hit 10.8 and it'll write right over it, and then just hit enter. So that's 5.2 or about 5.2. So we should maybe write our approximate symbols here. There we are, 5.2. And that does make sense with this other case over here. If we think about it, this angle C is only 10.8, angle A is 134.2, so we've got an obtuse triangle. And this side length AB, which is also C here, that one's going to be fairly small. And it's opposite the 10 degrees or 10.8 degrees, which is the smallest, so it does make sense. Great idea just to make sure all of this makes sense once you're finished. So we have case 1 and case 2. Each one of these are possible triangles, so you could say that there are two possible solutions, and then when we try to solve a triangle, we want to solve each one of those, and I'll move that back here so that you can see that.